Hi, welcome to the channel. So today we will discuss solve four problem asked in today's LeetCode Biweekly Contest 168. So let's start with the first problem. It says you are given a string s of length n that consists of lowercase English letters, and you must perform exactly one operation by choosing any integer k such that k is from 1 to n, and you can do either first operation, like either reverse the first k characters of s, or you reverse the last k character of s, right? And we have to return the lexicographically smallest string that can be obtained after exactly one such operation, right? So in this problem, what we have to do, we have to pick an integer k. Either you reverse the first k character or the last k character and just return the lexicographically smallest one, right? So this is the brute force like problem. So since the length of the string is only up to 1000, right? So we can easily apply order of n square solution. Now to solve this problem, what we can do, we can apply a brute force approach. Let's say this is a given string s. This is your given string s. Let's say its length is n is equal to nothing but s dot length, right? And we have to pick either, so we have to pick an integer k from 1 to n, right? From 1 to n, and we can either reverse first k character or the last k character, right? And out of all those possibilities, we have to return the minimum possible strings, right? So what we can do, we can simply go through each possibilities of k. So let's say I'm going through for int k equals to 1, k is less than or equals to 1, k plus plus, right? What we can do, we can first reverse the first k character. Let's say that string is s1. So s1 would be the string that can be achieved by reversing the first k character of s, right? And similarly, we can find out s2 would be the string that can be obtained by reversing the last k character of it, right? Then so let's say this is your answer is equal to initially empty string. Then what you can do, you can simply update answer is equal to minimum of answer comma s1 comma s2, right? That's it. So the complexity for this approach is order of n square, because order of n, to go through each possibilities of k from 1 to n, again order of n would be to reverse the first k character of it, right? So once you reverse it, that would again take order of n. So the overall complexity order of n square, and since your n is up to 1000, it can be easily accepted, right? So yeah, I hope you understand. Let's look at the code now. Here is the code. This is a given string s, right? So first face the length, and then what we will do, we will go through each possibilities of k. So k is from 1 to n. So initialize your answer with s, right? Because s is one of the possibility. Now what we can do, we can find out two strings s1 and s2. The s1 can be achieved by reversing the first k character. So reverse s dot begin comma s dot begin plus k. So this will reverse the first k character. Now s2 can be achieved by reversing the last k character. So now s2 can be achieved by s2 dot by reversing s2 dot end minus k comma s2 dot end. So this will reverse the last k character. And out of these two, s1 and s2, just update your answer. Answer is equal to minimum of answers comma s1 comma s2, and return your answer, right? So yeah, this is all about the first problem. Let's look at the second problem. In second problem, you are given two positive integer num and sum. Now a positive integer n is called good if it satisfies both of the following condition. The first condition, the number of digits should be exactly equals to num, and the sum of digits should be exactly equals to sum, right? And the score of a good integer is the sum of square of its digits. Now what we have to do, we have to return the string that denotes the good integer n that achieves the maximum score. So we have to return the good integer that achieve the maximum score by following these two conditions, right? The number of digits should be n, and the sum of digits should be exactly equals to sum, right? So yeah, this is an easy problem. Let's see how we can approach it. In second problem, we are given num and sum, right? And we have to find out a string that has the length equals to exactly num, and the sum of digits of that string should be equals to sum in such a way that the square of digit, like the sum of a square of digit should be maximized. So we can apply a greedy approach here. So first of all, let's see when the answer won't exist. So we know that the length of the string should be, like the length of that integer should be exactly equals to num, right? So what is the maximum possible sum of digit which you can achieve? That would be 9 into num, right? So num is the length, right? So what we can do in the maximized integer, we can do 999, so we can keep 9 at each of the position. So this is the maximum possible integer that you can achieve, right? So what is the sum of digit? The maximum sum of digit is 9 into sum. So check if your given sum is greater than 9 into sum. If that is true, like if your sum is more than 9 into num, then just return empty string, because like there is no possibility of getting any string that has the sum of digit equals to sum, because the max possible is 9 into sum. The second case, otherwise the answer always exists. What we can do, we can apply a greedy approach. We can keep 9, so we will start from left to right. We will try to keep 9 here, like in order to get the maximum score. The reason is, let's take an example. Let's say you are given num equals to 2 and sum equals to 9, right? So there are multiple ways to find out a good string. One could be 90, right? So sum of digit, the number of digit is 2 and the sum of digit is 9. One more possibility is 45. Now let's see what is the score of it. Score of it is 81. Square of 9 plus square of 0 is equal to 81. What is the score here? 4 square 14 plus 25. So the sum is 31 plus 41. See what it means? We know and like we can also think of this way. We know that a plus b whole square equals to a square plus b square plus 2ab. Think about this way. A square plus b, sum of a plus b square will always be more than a square plus b square. See, if you do 9 square, that will always be more than 4 square plus 5 square, because 2ab would come into picture. That is why the most optimal way would be to keep 9 as many 9s as possible, right, from the start, and after that just keep on putting 0 here, right? So let's take an example. Let's say you are given 25 and the length is 3. Let's say the length is 4, right? 25. So what we can do, we can keep 9, again 9, 9, 18, 7 and 0. So this is the optimal answer for that. 9. So here see, the digit is 4 and the sum is 25. So 9. So start keeping as many 9s as possible. So this is the ultimate approach for this problem, right? Yeah, let's look at the code now. Here is the code. You are given n and sum, right? So num and sum. First check if your sum is more than 9 into n, just return empty string, because the maximum possible integer which you can get is by keeping all the 9s, right? Otherwise, if your length is 1, then just return your sum. Just like the string format of the sum, because we know that if your n is 1, what it means? It means that this proves that your sum is always be less than or equals to 9. So just return corresponding string value. So let's say your sum was 8. So just return 8 here. So that essentially what it does. Otherwise, this is my answer. Now what I'm doing here, I'm trying to keep as many 9 as possible at the beginning, right? So we will start from left to right. We will try to keep as many 9s as possible. So while sum is more than or equals to, while sum is greater than or equals to 9, start keeping 9, as many 9s as possible. So answer plus equals to 9, sum minus equals to 9, and length minus, because now your length is decreased by 1. Afterwards, if your sum is not equals to 0, then just keep that character. Like for example, as discussed in the explanation part, see, the sum was 25, right? So 9, 9, 18. After that, what is left? 7. So we kept 7 here. That's what I have done here. I have kept that character, and then length minus, and after that just keep all the zeros, right? And then return your answer. So yeah, this is the code of third problem. Now let's second problem, sorry. Now let's look at the third problem. So here is the third problem. So you are given two integer array, nums1 and nums2. The length of nums1 is n and the length of nums2 is n plus 1. Now you want to transform nums1 into nums2 using a minimum number of operation. You may perform the following operation any number of times, each time by choosing an index I. What you can do, if you choose an index I, you can either increase that number by 1 or you can decrease that number by 1, or you can append nums1 at the end of the array, right? So you can do either of these three operations, and at the end return the minimum operation required to transform nums1 to nums2, right? Yeah, this is a good problem. Let's see how we can approach it. In problem number 3, we are given nums1 and nums2. The length of nums1 is n, and from index 0 to n minus 1, and the length of nums2 is n plus 1, one extra, right? Index from index 0 to n, and we have to convert nums1 to nums2. What it means, if you observe it carefully, it means that, let's say nums1 contains some number, let's say 3, right? And let's say the number at the first index here is 5. What it means? It means that we have to convert this 3 to 5 for sure. Then only your nums1, I mean, like after doing our operations, your nums1 would look like nums2, right? And in the operation could be either increment a number, decrement a number, or append a number to the end, right? So if you have 3 here and if you have 5 here, what we can do, we can apply 2 plus 1 operation at here, and we can convert 3 to 5, right? So let's say there is a variable called total operation initialized with 0. What we can do, we can easily use a for loop for int I equals to 0, I less than n, like for all the numbers in the nums1, I plus plus your total ops plus equals to absolute value of the difference between nums1 of I and nums2 of I, nums1 of I minus nums2 of I. The reason why I have taken a modulo here is because let's say to convert 3 to 5, like we have to do plus 2 plus 1 operation, right? Let's say the number here, for example, 7, and here let's say the number is 3. So here we have to apply minus 1 operation, right? Minus 1 4 times minus 1 operation, so that we can convert 7 to 3. But ultimately, how many number of operation which you are doing? The difference between these two numbers, right? That's why I have done ops plus equals to absolute value of the difference. So it will take care of both plus 1 and minus 1. But if you just apply this operation, the job is not done. This will convert the first n numbers to the first n numbers of nums2. But what about this? But what about the last number? It means that we have to apply at least, not at least, exactly one append operation, right? We have to apply exactly one append operation in order to convert nums1 to nums2. So using this concept, we have successfully converted the first n number to the nums2. But now we will think about how to optimally choose an operation for the last number of nums2, right? Let's see what we can do. Let me remove this part. I hope you understand this. Now let's think about the last number. Like let's consider any generic number, let's say. And one more thing, this append operation would be applied on the nums1, right? So what it means? It means that we have to convert, we have to append any of the number at the end, right? So let's take any generic number I, like the index I. Let's say the number here is nums1 of I, and similarly the number at this index is nums2 of I. So there are 3 cases. The first case, if your nums of I is equals to nums of 2, right? If both are equal, right? If both are same, and we have to convert this number to, so let's say this number is last. Let's say I'm calling this number as last number, right? If both are same, what it means? So in the original operation, you won't be doing any plus 1 or minus 1 operation, right? Because the number is anyway same. Let's say this number is 3 and this number is also 3. Then why do I do any plus 1 minus 1 operation? So I won't be doing any operation. It means that if you want to convert 3 to last, what we can do? We can first append this 3 at the end, right? We can append this 3 at the end, and after that we can do either plus 1 operation or minus 1 operation in this to convert into last. So in this situation, so let's say for the last number, your minimum operation is, let's say I'm calling it min ops. That is going to be minimum of mean ops comma 1 plus 1 because I have to append, like I have to apply one append operation, plus again difference of absolute value of last minus this nums1 of I. I hope you understand. Let's understand from example. Let's say the number was 3 and the last number was 5. What we can do, we can apply a append operation. So one operation to append. So after that this number would be 3. Then we can apply 2 plus 1 operation, right? 2 plus 1 operation. So that 3 can be converted to 5. So now we have achieved 5, right? That's why 1 plus absolute value of last minus nums1 of I. Now let's consider second case. If nums1 of I is more than nums2 of I, right? This is my nums1 of I, and this is my nums2 of I, right? What it means, if nums1 of I is more than nums2 of I, we have to apply this minus operation, right? We can let's take an example. Let's say this number was 5, this number was 3, so we have to apply minus, like 2 times minus 1 operation, right, to convert 5 to 3. Now let's consider cases where your last present. If your last present here, right, if the last is more than this 5 nums of I, what we can do, we can keep 5 at the end, and then we can apply let's say the number was 7, we can keep this 5 at the end, then we can apply 2 plus 1 operation, right? So here your minimum operation would be so I'm not going to write once again. So it would be minimum of that comma, here the number of operation would be 1 plus append operation plus difference of last minus this nums1 of I, given your last number is more than nums1 of I. Second case, if the last present in this range in between nums1 of I and nums2 of I, here if you observe it carefully, you don't have to apply any plus or minus operation. The reason is let's take an example. Let's say the nums1 of 5 was 5 and nums2 was 3 and your last was 4. It means that you have to convert 5 to 3, right? And we have so if you remember in ops, we have already did plus equals to 2. What it means that, so what it means, we have first converted 5 to 4 and then 4 to 3, right? Since last comes in between these two number, so whenever the last come, right, we can easily do append operation there. So here just append that operation. So here the number of operation would be just 1. You don't have to apply any plus 1 or minus 1. And similarly, if your last present in this range, right, if it is less than nums2 of I, the operation is going to be 1 plus diff of the difference of last minus nums2 of I, right? I have to understand, if you watch this video once again, you would understand that like this problem is not that hard. It's easy problem. Is like if both are same, just apply 1 plus your operation is going to be 1 plus absolute value of difference of last and nums1 of I. If this is more than this number, then just check where your last present. If your last is more than this is the operation. If your last present in between these two numbers, for example, this nums1 of 5, nums2 is 3 and your last is 4. So like we anyway have to convert 5 to 3, right? So 5 would be converted to 4 first and then 3. So whenever you come to 4, just append that number. So here the operation is just append operation. So one operation, no need to do any plus 1 or minus 1. And similarly, if your last lies in this range, your operation is going to be 1 plus difference of last minus nums2 of I. And same applies for the third case when this is less than that. So if this is less than this, just check where your last present in this range or in between them. So if it's in between them, again the operation is going to be just 1. Otherwise 1 plus append plus the difference of that number and the minimum number, right? So yeah, I hope you understand this part. Let's look at the code now. Here is the code of third problem. So we are given nums1 and nums2. So this is the size of nums1 and we know that the size of nums2 is n plus 1 extra. Now this is the ops, the total operation to convert nums1 to nums2. So please check out the explanation part first. I have explained there, then only you will understand this code properly. So initially convert first n number of nums1 to nums2. So the operation is going to be the sum of the difference of nums1 of I and nums2 of I. After that, let's find out the last number of nums2. So last number is nums2 of n. Now this is the minimum operation to convert any one of the number from nums1 to last number, right? So because we have to append this number, so and this will tell you the minimum operation to convert any one of the number to last number. So what we will do, we will go through each of the possibilities, each of the number from 0 to n, like in this nums1. We will first check, like, so this code is exactly same I have explained there in the explanation part. If they both are same, the operation is going to be minimum of 1 plus 1, because I have to append operation, plus the difference of nums1 of I and last, because after that we have to do either plus 1 or like increment or decrement operation. And if the nums1 of I is greater than nums2 of I, just check where the last present. If your last present in between the range, in between the range, your operation is going to be 1, right? Because we anyway have to convert so let's convert nums1 to nums2. So let's take an example. Let's say this was 5, this was 3. So and your last was 4. So we know that to convert 5 to 3, we will anyway reach 4 at some time, right? So 5 to 4, then 4 to 3. And if since your last was 4, just append it. Don't do any increment or decrement operation. So minimum operation is 1. Otherwise, just take the difference of 1 plus 1 because of append operation and absolute value of the difference. And same applies if your nums1 of I is less than nums2 of I. Like the same concept. And at the end, return the number of operation to convert first and number, then minimum operation to convert like any one of the number to last number by appending. So yeah, this is all about the code. Let's look at the fourth problem now. Here is the fourth problem. You are given m cross n matrix, right, of positive integers. We have to return an integer that denotes the number of ways to choose exactly one integer from each row of matrix, such that the greatest common divisor of all the chosen integer is 1. So essentially what we have to do, so let's say we are given a matrix. We will choose one of the number from each of the row, and we have to find out how many number of ways exist, such that if you take a GCD of all the chosen number, like so chosen single number in each row, the total the GCD of all the numbers, all the chosen number is 1, right? So and we have to return it by taking modulo 10 to the power 9 plus 7. Yeah, it's a good problem. It's essentially a DP problem. Let's see how we can approach it. This fourth problem can be solved using dynamic programming. So we will use a 2D DP, where DP of ij tells you the number of ways such that the GCD of numbers chosen in each of the row from 0 to I is exactly equals to this j. What it means in simple terms, let's say I am at any particular row. Let's say the row is I, for example, right? And I want to calculate what is, we know that your numbers could be up to 150, right? Your numbers is only up to 150. So what we will do, we will try to find out what is my DP of ith row, 1. Then I will calculate, similarly I will calculate DP of I, 2, and so on up, and similarly we will calculate DP of I and 150. What this DP of I1, I2, what it means? DP of I2 means that so if you choose one number in each row from index 0 to I, your total GCD should be equals to 2. Like, so this DP of I2 would tell you the number of ways to choose one number in each row from 0 to I, such that your total GCD is 2. That's what DP of I2 tell you. Similarly, DP of I 150. The number of ways to choose one number in each row from 0 to I, such that the GCD of all the chosen number is 150. That's what this DP of ij tells you, right? Now what will be your answer? Your answer would be, similarly your answer would be DP of n minus 1, 1, right? This is your answer. DP of n minus 1, 1 means the number of ways to choose a single number in each row from 0 to n minus 1, 0 to n minus 1, such that the GCD is 1. That's what the problem asked you, right? So your answer is DP of n minus 1 and 1. Now let's try to find out how to build this DP, how to find this DP of I1, I2 and I3 and so on, right? Let's consider a case. Let's say this is my ith row, right? In ith row you have a number, let's say any generic number, x, for example. Let's take an example. Let's say your current number is here is x, right? What we will do, we will try to go through each of the possibilities in the previous row. So let's say this is my ith row. In I minus 1th row, in the previous row, we will go through each of the numbers from 1 to 150, right? Since I am at ith row, it means that dp of I minus 1 1, dp of I minus 1 2, like dp of I minus 1 1, similarly dp of I minus 1 2, we already know the values of these two, right? That's why I came to index number I. dp of I minus 1, so what it tells that the number of ways such that the GCD of all the numbers from index 0 to I minus 1, if you choose a single number in each row from 0 to I minus 1, your total GCD is 2, right? What we will do, let's say that number is u. We will go through each of the possibilities of numbers from 1 to 150, and I will again go through each of the numbers in this row. Let's say that number is x. I will do dp of I and GCD of, let's say this is GCD of x comma this previous number, like all the numbers from 1 to 150, u dp of I GCD of x comma this plus equals to dp of I minus 1 and u. I hope you understand this recurrent relation. This is most important relation. If you understand this, you understand this whole complete problem. So your dp of I GCD of x comma u, because this is my current number and I'm going through each of the possibilities of numbers in the previous previous row for all, I mean all the ways to get the GCD, right? Because we know that the number is up to 150, so the GCD will also be 150, up to 150. I'll go through each possible GCD in the previous row. I will take GCD of current number and the previous number. Let's say the number was u, plus equals to what it means, the number of ways to get this GCD of x comma y, GCD of x comma u from index 0 to I equals to the number of ways to get this number will be plus equals to the number of ways to get GCD u at the previous index, right? And after that we can take the GCD with x. So yeah, this was the recurrence relation. I don't think it's unobvious. I mean it's pretty obvious if you have solved at least one DP problem in a matrix. So yeah, this was all about the explanation part. Let's look at the code now. This is the code of fourth problem. So we are given this matrix, right? Matrix. This is my number of rows. This is my number of columns. Now I have built a dp of n 150 because your GCD can go only up to 150, right? Because the number is only up to 150. So, and we know the definition of dp of ij. Please check out the explanation part, and if you still feel any kind of like difficulty to understand, please write a comment. I'll explain to each one of them in the comment, right? If you have any problem to understand. We know the definition of dp. So dp of ij would tell you the number of ways such that the GCD of chosen number in each of the row from 0 to I is exactly equals to j. So initially all the dp of ij equals to 0. Now in the first row, dp of 0th row and that number, because the GCD of a single number is that number itself. So dp of 0, matrix of 0 comma j, each of the number in the column, plus plus, right? Now from index 1 onward, second row onwards, we will go through each of the numbers like in each of the columns. So my current number is dp matrix of ij, right? This is my current number in ith row and jth column. Now what I'm doing here, I'm going through each of the possibilities of getting GCD in the previous row. As per the explanation I have, I have already explained that. This is all the possibilities of previous GCDs in the previous row. Now my current GCD is GCD of current number, this matrix of ij, comma, this previous number, right? So this is my new GC. Now similarly, as per the recurrence relation, dp of I GC plus equals to dp of I minus 1 u. So the total number of ways to get GCD GC from by choosing one of the single element from index 0 to I in each of the row from 0 to I is equals to get the number of ways to get GCD u at the previous row, right? And similarly just do modulo with mod, and at the end return, and your answer is going to be dp of n minus 1 1. What it means? It means the number of ways to get GCD equals to 1 by choosing single number, single element maybe in each row from index 0 to I. That's what the problem asks you, right? So yeah, I hope you understand the solution of all four problems. If you find the video helpful, please like, share and subscribe to my channel. Thanks for watching.